The difference of two numbers is 3. So let's call these numbers x and y. And the word difference means we subtract. Is means equal. This is equation number 1. Their sum is 27. So x plus y equals 27. We'll call this equation number 2. Let's solve x and y. For these systems problems, we can either use substitution or elimination. It doesn't really matter. Let's draw a line and we'll use elimination. We can either add or subtract equations. In this case, let's add equation number 1 plus equation number 2. X plus x is 2x, and negative y and positive y, they cancel out. Equals, we're adding 27 plus 3 is 30. Thus, x equals 15. Let's substitute x into equation number 1 here. 15 minus y equals 3. Thus, y equals 15 minus 3, which is 12. The smaller number is 12, and the larger number is 15. We found the numbers. 3 nuts and 5 bolts weigh 16 ounces. So let's write this equation. 3n plus 5b weighs equals 16. Let n be the weight of 1 nut, and let b be the weight of 1 bolt. Whereas 2 nuts, 2n, plus 4 bolts equals 12. This here is equation number 1, and this here is equation number 2. Let's use elimination to solve n and b, the weight of a nut as well as a bolt, which is what we're trying to solve. Let's find the LCM. Let's find the LCM of 3 and 2 in order to cancel out the n's. So let's make equation number 1 a 6n. So we're going to multiply equation number 1 by 2. We have 6n plus 10b equals 32. And we'll multiply equation number 2 times 3. So we have 6n plus 12b equals 36. We now subtract bottom equation minus the top. 6n minus 6n cancels out to be nothing. 12b minus 10b equals 2b. Equals 36 minus 32 is 4. Dividing both sides by 2, we have b equals 2. The weight of a single bolt is 2 ounces. Notice that in order to solve for b, we cleverly canceled out the opposite of b, which is n. Let's try this system's word problem. Your boat travels 50 kilometers from A to B, and the distance is 50 kilometers, downstream. Downstream means that you go a bit faster than usual because the current is going this way, making you faster. The trip downstream takes 4 hours, so we'll write that time equals 4. You return to your starting point by traveling upstream for 20 hours against the current. So when we're going this way, the time takes 20 hours. What is the speed of the boat in still water? So we're trying to find v, the velocity of the boat in still water, not including the current. So recall the classic formula, distance equals velocity times time. When we travel downstream, we have distance equals velocity plus the current because we go faster than usual, multiplied by time, which is given as 4 hours. And we know that the distance is 50 kilometers. We'll call this equation number 1. On the way back, we also travel 50 kilometers. However, the velocity is not faster by the current, it's actually slower by that same current. And the time is given as 20. 20 hours is a long time. We call this equation number 2. We now have two equations and two different unknown variables, v and c. We can solve for these variables. Let's expand out equation number 1. We have 50 equals, using distribution, we have 4v plus 4c. This is equation number 1. As for equation number 2, we have 50 equals 20v minus 20c. Let's divide equation number 1 by 2. We have 25 equals 2v plus 2c. And we'll divide equation number 2 by 10. We have 5 equals 2v minus 2c. Let's now add these equations. 25 plus 5 is 30. 2v plus 2v is 4v. And positive 2c minus 2c cancels out, so it's plus 0. Dividing both sides by 4, we have v equals 30 over 4, which is 15 over 2. This is equivalent to 7.5. So the speed of the boat in still water is 7.5 kilometers per hour.